Here's my gripe with calculus. Every description under the sun kind of starts off talking about slices and stuff, so this is actually quite a good reference, mathisfun.com. I kind of go through this with my kids, and I think their explanations are quite good. But this is every explanation of calculus always starts off with the area bit. We're talking about the area bit of calculus. Always starts off with this. We could start slicing things up, but what we want to do is slice it up infinitely. So we're talking about slices, and that's a lot of adding up, but there's a trick that we can use. My gripe is, maths isn't about a trick, it's about trying to understand why it works. So if we go back to basic stuff that we know about area, so say you've got a rectangle, and you've got x there, and you've got y there, and you want to know what is this area in here. Well, that's easy. It's x times by y. Don't write that. We write xy is equal to area, right? Let's try a circle. We all know that this is the radius to the center, so the area is equal to pi times the radius times the radius. Pi r squared equals the area of that. Now, calculus is talking about curves, but this circle's still a curve. You put it on an xy graph, that's still a curve. So you can use, that is an equation that describes the area. If we start, I love triangles, okay? All triangles, whatever their size, if we got them on an xy graph like that, this is a right angle. This is the start of the triangle, it's the end of the triangle, you've got your x going on there, and you've got your y going on here. So how do we describe the area of a triangle? Half times x times y. Why is it half? Because we want this area here, and we do not want this area here. The triangle's pretty obvious in my mind when you think of it that way, why that half exists. Half times x times y. When we go into calculus, we're taught that, okay, so say like forget this side of the graph, say we were just working out this side of the graph, x is y, so I'll draw that out again, and instead of going that way, which would be inverse, we've just got a dead easy, that's your y, that's your x. The equation that describes that graph is y is equal to x. You want to work out the area underneath y is equal to x, same as when we had our triangle. The area is equal to whatever point you get up to, so say that is x is 5. 1, 2, 3, 4, 5. If you want to know the whole of the area there, all underneath there, then it's just x times x squared, and then it's half of that, because it's a triangle. The area underneath that curve is x squared divided by 2, or half x squared. Exactly the same as the triangle. So kind of get that in your head, and that's the way of thinking about it. Now if you want to know the area from 2 to 5, you're only worried about this bit here, that's dead easy. You can work that out by taking away this bit here. In this case, area is x squared divided by 2. We need to say we want to work it out between 5 and 2. Then we'd work out x5 squared, 25, minus 2 squared, 4, divided by 2. 5 squared minus 2 squared, over 2. That's the rule. That's what's going on with this graph. So that's the simplest graph, y is equal to x. If you can kind of like understand that's all you're doing in calculus, it becomes a lot easier. And I'll start to make it make more sense now, hopefully. We'd all love to have that question in our exams, but it doesn't get, it's usually something a little bit harder than that. But if we just make it one step harder, so it's curving upwards, y is equal to x squared. So when x equals 5, y is equal to 25. And of course we write that in maths as function. Say we want to now work out this area here. So if you remember before, when this bit here was a straight line, we were using our good old triangle equation where it's just you add that, because it's kind of like a square with half of it taken away. So you work out what the whole triangle is, and then you take away the small triangle. We can't do that now because this is curved. This is a curved line. But it's a similar process. So instead of y is equal to x, y is now equal to x squared. But in order to work out the area, we do the same thing. We do the big triangle, so we work out the whole area of the graph, including this bit, and then we work out this bit and take that away. But it's not just, before it was just 5 and then times 5, because that was the square and then halved. Does that make sense? This is kind of like the critical bit. If you can get this, this is like the aha moment. So I'm probably not doing a very good job of explaining it. But because this is now a curved graph, 5 squared times by x, which is 5 again, and before we had to divide it by 2 because that was a straight line. Because it's a squared line, it's going up to the power of 2, we have to divide it by 3. Okay? So that is just written as is 5 to the power of 3 over 3. And you just kind of have to make your peace with why that is over 3 and not over 2. It's because that's a curved line. So if it was over 2, that would be a straight line. As you can see, it would be occupying much more of the area. You would be getting all this bit as well. And then we take away the smaller triangle here, minus 3 to the power of 3 over 3. So the area is, in order for it to be clearer, when you say area and you want to be explicit about 3 and 5, that's when you start getting this this crazy symbol. So we would write, in order to solve this, that's when you start seeing this. Looks like a fancy big S. So what we've been doing up until now is the full area of the graph. Then when we started doing it between two areas, we were talking about a definite integral, so it has start and end values, and the a is the smaller number, which goes at the bottom, and the b is the top value, which goes there. And this means the sum. This means add up everything between a and b, and that's why they start off explaining it as cutting it up into an infinite number of slices and adding them all together. And obviously, as the slices are smaller, the area that you're timesing it becomes closer to 0. So that's why you want to be solving it using a formula, the actual formula, and not approximating it by using slices with a width of 0 that you can't calculate because there's no area if it's 0. If that makes any sense. So, but I mean, as soon as you get dropped into calculus, you start seeing this, and they start explaining that before they've done the bit that I've explained. So hopefully by starting from basics, where we were talking about the triangles, it makes a little bit more sense. We've got our 3 there, we've got our 5 there, and then they've said, so this is for 2x would be, y is equal to 2x, so that's with a gradient of 2 underneath, and then dx at the end. And we'll come on to why it's dx at the end. Don't worry about why it's dx yet. We'll do that in a later video. So what we're saying here is the integral of 5 over 3, and then whatever the function. So ab fx dx. So fx is equal to x squared. So the answer to that is 32. I hope that makes sense. Anyway, that's the way. It took me a while with calculus before I could go. I had my aha moment and then realised, well, hang on, it's just the same rule as if we're dealing with triangles. If you can lower it in terms of a dimension or lower it in terms of a power of what you're dealing with and look at what the rule is and why it logically makes sense, you can kind of hold it in your head. And when you've got an idea of how it works in your head, it becomes that much easier to, when you're writing out the formulas and stuff like that, you can sort of see if something's going wrong. So if you've got a rough idea of that sort of graph in your head, and you go in, well, 5 cubed over 3 is like the area of that whole triangle, and 5 cubed over 3 is 41. Does that look like 41? Yeah, it kind of does. And does that look like only 9? Yeah, it kind of does, so that's all right. And I just find it much more easy if you can like visualize stuff. Anyway, that's area, and I'll do another video on the other angle of calculus, which is where we work out gradients, so how steep the curve is at different points. Because the point is, there's integration, and the two sides of calculus basically move you between area and steepness of the graph, and we'll cover that in the next video.